Hello, my name is Tyler Ray. I'm a geology major in my senior year here at Radford University. And today I want to discuss a comparison of glacial rocks of the Konnarock Formation to Snowball Earth deposits around the world. And I've been mentored throughout the summer research process by Dr. Beth McClellan. So Snowball Earth and deep time. And what exactly is deep time? Well, from our geologic perspectives, deep time is a multi-million year time frame spanning far back into Earth's history. And understanding these processes that occurred over deep time can help us better understand natural climate events, of the past. So during the Tonian period of the early Neoproterozoic era, there was a supercontinent named Rodinia, and it began to split apart, causing massive rifting and volcanics around the world. And it's around this time that the Mount Rogers volcanics were formed. So, at approximately 720 million years ago, was the start of the cryogenian period of the Neoproterozoic, and this was the most intense glaciation event in Earth's history around this time. So, known as the Snowball Earth, it is suggested that during this time, conditions would have become so cold that ice sheets would have covered the entire globe, leaving oceans and landmass covered in ice as far down as the equator. The main Snowball Earth glaciation event is thought to be the Sturtian glacial event from approximately 717 million years ago to 662 million years ago. The glacially deposited Konnarock is thought to have formed around this time in what is now southwest Virginia and northwestern North Carolina. And I wanted to show you my figure over here, and I'm sorry about the recording covering some of it. But you see here in the Tonian period was the rifting and Mount Rogers Formation volcanism. We get into the Cryogenian, where the Sturtian glaciation happened, and then later on in the Ediacaran, there was non-glaciogenic sediments. So here is an image of the Sturtian glacial deposits found around the world. If you notice, this glaciation would have been a global event, and right in here in the red circle is the Konnarock Formation. So very little studies have actually been done on the Konnarock when it's compared to other Snowball Earth deposits. And the little yellow dots just represent regional scale deposits, and then the little red dots indicate sedimentary iron formations from that time as well. And if you notice, the Konnarock is really the only key deposit on the eastern United States, And even though the continents at the time were in different locations, you can still see the dots show that there were glacial deposits found across the entire globe, and they would have formed all around the same times. So, around the Mount Rogers recreational area in southwest Virginia is where the glacially deposited Konnarock is found. And I wanted to show you here with my figure, kind of where the area that I'm talking about. So, this is obviously Virginia, West Virginia contact up here, and down here's Tennessee, and this whole bottom would be North Carolina. And right here's Roanoke, kind of as a perspective. So if you look down here in the little box with the green in it, that was our area of study, which this is the Mount Rogers recreational area. So this is a type of map that we use called a geologic map, and these types of maps are used to show where formations lie and how the rocks are oriented. So the youngest volcanic rock of the Mount Rogers Formation is around 749 million years ago, meaning the Konnarock must be younger than that according to the law of superposition, which just states that the oldest rocks would be on the bottom and progressively getting younger as they stack up stratigraphically. And in this figure you can see that the blue is mostly Konnarock, and it shows the contact with the volcanic units, which is the pink colors here. So sedimentary Konnarock can't be dated properly due to being made of many sediments from other sources. But, however, our volcanic rhyolites, which is what is mostly Mount Rogers Formation consists of, are perfect for zircon age dating. And the contact points is, where we focused and where we propose to date and reveal a more accurate age of the Konnarock. So the Konnarock itself is comprised of a typical glacial deposit that are still like the ones being formed today. As global glaciation advances and recedes across the landscape, it forms a very fine-grained, what they call till, that is just deposited directly where the glacier has been. And it's thought that there was probably a large glacial lake at the time, and the glacial sediments would have been deposited in and around this lake environment. Mudstones, like the ones I got shown in my image here, are fine-grained clay-sized materials that are very characteristic of cycling glacial deposits. If you look, there's different colored bands in my figure, and these are known as barbs. They are like a pair of thin layers that just represent the deposit of a single year cycle. One of winter, which is fine clays, that would have been suspended in the water. They can finally be deposited out. And then during the summer, even though it was very cold at the time, there could still have been somewhat melting, which would deposit the slightly larger materials. And so if you look really closely, you can see that each one of these pairs of bands represent 1 year going on up. So more evidence of this being glacial deposits is there's drop stones, which are just larger rocks that have been carried by ice sheets and then eventually dropped off. So the drop stones have been found throughout the Konnarock and are defining characteristics of a glacial event. And if you actually look in my image right here, if you see the lighter colored pink rock in the top right is actually a drop stone. So this would have been carried by a large glacier and then melted or dropped out, and it landed in this sediment and then was eventually captured within it. And those are very defining of glacial sediments. So this image is showing diamictite, which is a poorly sorted sedimentary rock with this one has large granite clasts and other smaller things within it. And the dark maroon color is our glacial sediments, like the till I was talking about earlier. And it would have been deposited with the larger clasts that were picked up along the way. And you can see that's a pretty big clast right there of granite, and there's some other smaller ones throughout it. So dating these clasts found in the diamictite could help us with the age dating process, because things found within this rock would have to be older than the rock itself. So some of my field methods. Over the summer, Dr. Mack and I, we actually traveled to the Mount Rogers area to collect hand samples, ourselves, to make sure we're getting the right things. We would begin our day with a sit down, and we would discuss, what our intentions were for the day, and deciding, which area would yield the best samples for our dating. So along roadways, there's rocks exposed all the time, and by road cuts, and these are great for examining rock formations and orientations. But as field work proves, not everything we need are as easy to acquire. So a lot of our time was spent in the deep woods, searching for rock exposures, formations coming out. So once we would say find a good exposed rock formation, we would attempt to take what is called a strike and dip of it, and that's just so we can find which way the rock is oriented in the ground. Normally rocks would just lie horizontally, but us being in the Appalachian Mountains, all these formations have been heavily altered, twisted, and turned. So once we got it mapped, and we would make a station, record it in our field journal, we would, might take a sample from this area if it seemed promising. And over the course of 10 days, which was, it was all separate trips, but 10 days altogether, we collected over 30 desired rocks and packed them out of the woods and brought them back to the lab. I like this image. It's kind of funny. I'm wearing a poncho. We were pretty tired, and we decided to stop and eat lunch, one evening, pretty far back in the woods, and just out of nowhere, one of those summer rainstorms hit and absolutely drenched us. And that's just that's a classic example of the challenges you'd face in field work. You always got to be on the lookout for wildlife and insects. I remember in that area that time of year, ticks were pretty bad then, and sometimes the terrain is pretty unpredictable, and you don't want to fall off a cliff or something. And that's just some, everyday challenges you find in the field. But, hey, we're geologists and we love it. So, eventually we would get back to the lab, and this is where we would begin trying to do some detrital class dating and, directly dating the volcanic bodies for us to best determine an accurate age of the Konnarock. So the first thing necessary in our lab work was to properly store the samples so they don't get lost and confused. And then we would narrow them down, and we would make cuts and eventually make into thin sections on the rocks we found desirable. So the process of making a thin section requires using many different saws to cut the rock down into, a proper size. So the first thing I done was I took the big raw sample and I would put it on this big saw called a slab saw, and I would cut them down into, slabs, something that's easier to work with when trying to make it into a thin section. And actually, this saw and a lot of our equipment in the department now are brand new with the upgrades it's been made with the building. So it's the first time any of this has been used other than testing. Next, a diamond bladed saw is used to cut the samples down into about the size of a glass slide, and then be epoxied to that slide. And then we'd use a grinding tool to get the samples down to a more correct size that we can use our new PM6 machine, which will make the final grinds, to the size we're looking for. And once it's done, our thin sections will be around 30 microns, give or take, and then we'll use a petrographic microscope to see the grains on the microscopic level. And I like this image. It's me using a couple of the different saws that we have here. So on the right, I'm using the grinding saw, and this is what you use, after you've epoxied the sample together to grind it even smaller. And it seems kind of dangerous, having my hands this close to the blades, but these are, special, like diamond-coated blades that they won't cut your skin unless, you really push down on it, and kind of like the saws you would use to cut a cast off your arm. It's not gonna hurt you unless you're just being careless with it. So currently I am still in the process of learning to use this new equipment, but nonetheless my research is still continuing as I finish up making these thin sections. And once it's been completed, I'll move on to the petrographic microscope in search of the zircons, which is a silicate mineral that is pretty well resistant to weathering and perfect for radiometric dating. And this process will narrow down the final samples that we wish to have dated. And once we get these samples, we will send them off to a geochronology lab. They will crush the samples and expose them to uranium-lead radioactive dating. And we actually was planning on going to the lab ourselves, but COVID-19 happened, and that pretty much put a stop on our travels. So the results from this, will hopefully yield a more accurate time frame that can be placed on the formations, and we can finally piece together, the possible events that led to the Konnarock Formation. And with this information, we hope to be one step closer to, revealing the causes of this massive glaciation event, how Earth and early life might have recovered from it. And, these are all very important aspects, needed to understand the past and, hopefully help us make predictions for the future. And I wanted to give a special thanks to my audience who took time out of their day to watch my presentation. Thank you to Dr. McClellan, who mentored me throughout this entire process, all the field work, lab work, my presentation. She helped a ton with that. And also I wanted to thank all the other presenters and the SURF team who have been giving me ongoing support throughout this whole process. Thank you guys so much, and I hope you all have a wonderful day.